Okay, human psych class. Good morning, or good day, or good afternoon, whenever you're watching this. But I'm going to have a little fun with you today, and this will actually be a little bit short. I'm going to make a number of these this week. You will see today, as I go through these slides, how much more fun this could have been in class. So, as we go through them, have your notes open. Just put today's date and seriously do your best to write out some things. I'll give some kind of longer pauses during this presentation. And if you need to come back at the end of this presentation to fill in some details or add to it, certainly go ahead and do that. It'll make our online discussion a whole lot more fun if you've got some things to kind of throw in there. Again, this is kind of fun, speculative, and easy to do, but I want you to give as much as you can to it because it'll make our time more enjoyable. And sorry to be repetitive, I can't stress enough how much more fun it would be if you were in class and we were just kind of shooting from the hip um, with what you're about to see. So here you go. I'm going to show you probably several pictures here. And if you were to create a story, what would you say about this picture? Set the scene for me. Tell me what just happened, etc. So here we go. Here's our first one. Go ahead and write something down. It could be just 5 sentences, it doesn't matter. But set the scene for me. Do you want to give them names? Do you want to pick the time of day? Why is he lying the way he is on that bed, and why is she crying? He's turned away from the window. Be as detailed as you can. Have some fun with it. Play director in a movie. Set the scene. I'll give you 30 more seconds. And scene. If you want to come back to that and add to it, a triple dog dare you. It'll be a whole lot of fun. So this is actually a way, and it's a good thing of getting people to drop their guard, to focus on something besides themselves for once, and to project onto a still image of what they think is happening. It's not like super revealing, but it can bring up some things maybe to talk about. If we were in class, I would have you write down your stories and then turn to each other, tell each other your stories, and then just ask the very simple, non-threatening question: why did you choose that? Why'd you say this? And did you name them? And oh my gosh, I did too. And it's just a way to get the mind going and to start learning about someone else and why they chose the things they did. So it's actually a pretty fun technique. I like it. I don't know how much you could actually diagnose from that about anything, but it's a good way to start. Here's two more. Call the one on the left, with the guy with his arm over his face, picture 2, and then the man and the old lady, picture 3. Picture 2, I think, is with the woman lying on a bed. I think she's dressed. I can't tell in this cartoon, but he is. So what is that? Look around. There's books on the table. See a doctor? Did he just come home? What is happening here? Is he an old man? And that's a young daughter, maybe? No. And then in picture 3, clearly this is a cold setting or something's wrong. So have fun. I will give you a minute for both of those. You can pick one or do both and set the scene again. Tell me a cool little story about what just happened. 1 minute. 30 seconds. All right. So again, in class, it would have been fun to have you do a kind of a think, pair, share kind of deal where you swap stories and got to know each other a little better. Maybe shocked of why'd you say that? And oh my goodness, that's really dark, or that was silly, or that was fun. And so it's a way to loosen up and get the brain going because it is really difficult to come up with a proper psychological test. You've probably done the personality test that we're going to talk about. If we haven't already, I don't know when the timing of this is going to go down. And then, these pictures were a fun way of trying to get access to how someone deals with patterns, how they take in information, how they process visual data. But really, the name of the game, if you want to write down a trigger word, a keyword that we're talking about, is interpretation. Our brains have to interpret, reinterpret, recode, rebuild our physical environment from our senses. The only thing, we'll talk about this when we do neuroscience, the only thing that our brain actually gets direct contact with are the electrical signals coming into it from sensory data. It doesn't have pictures or sounds coming in. It just has electrical signals, and it has to reconstruct them and interpret what's the frequency or the magnitude of the signals. And so what you're experiencing right now is the highest resolution of VR possible. I know that's really strange to consider, but everything you see and think and feel and hear and touch is reconstructed from electrical coding that your brain is receiving. It doesn't see or hear or touch or smell anything. And so the name of the game here for the physical senses is interpretation. And then if you keep going up into higher levels of cognition, how we deal with people, how we deal with situations, how we start to process patterns is all interpretation. And so that's what's happening here, you know. So what do you see? Go ahead and write something down if you want, but this would be something that we just talked about. So these are low-level fun things when we talk about, say, cartoon pictures of people and scenarios and trying to come up with a narrative or a story. Or if we look at ink blots and try to see, because of the symmetry, patterns involved. And so it's a fun way to try to get at what in the world the brain is doing with interpretation. So, like, for example, in the first one, I feel like I see a fat clown with runny makeup squinting and kind of smiling. I don't know. It's weird. Maybe y'all see two people facing each other, whatever. This one, two animals walking straight up the side of a cliff. I don't know. So, anyway, just having fun with you. So if we move to logical reasoning, you've probably seen this before and done it. You can only have 4 straight lines to connect all 9 dots. If you've never done this before, without retracing these things, it can be quite frustrating because you run out of lines very quickly. Okay. So this would be a fun thing that we would have done in class to see if you can figure out where would you draw the first line. Right. See what happened? It went outside the perimeter. And so you have to move outside of the grid of the dots. Now don't call this thinking outside the box, because I hate that phrase. There is no box. This has to do with you setting a limit for yourself with the 9 dots when that was never actually told to you. So it was almost, the solution to this was almost, can you take a particular shape and impose it upon those 9 dots so that it touches each dot, rather than staying inside the grid and using only 4 lines. And so anyway, imaginary boundaries, if you take this simple example and apply it to relationships, life choices, it actually becomes a bit of a polemic, an argument, something to think about. So this is where psychology, when it looks at how people interpret images or how they do logical reasoning, you begin to see the brain's limits, the way it processes new scenarios. Some people, when they encounter a new scenario, something unfamiliar, and even a bit disturbing, they will break off boundaries and find a number of solutions to these things, see how many choices they can come up with. Other people restrict and lock down to reduce the number of variables and try to solve it in a more conservative fashion. So this is what it kind of means to do psychology, to try to figure out how someone's mind that we can observe processes things. So we have to have some actual external behaviors to observe. So this will be really fun in class. I'll record myself doing this in just a minute. You're going to see a screen come up that's got 4 different words in 4 different colors, and you can try this. I'll have you do it first and then I'll do it. But go ahead and do it at home and do it out loud. You're going to sound like a crazy person. So if you need some privacy, you can hit pause and go close the door or something like that. It's not a big deal, but you might be self-conscious. And so this is what the Stroop effect is. So here you go. Read the colors, not the words, and watch what happens to your brain. So you go first. Okay, my turn. Listen to what happens to the speed of how my brain is processing this. So I'm supposed to read the colors, not the words. Red, blue, orange, purple, orange, blue, green, red, purple, blue, blue, red, green, orange, red, green, orange, purple, orange, blue, purple, green, orange, red, purple, red, blue, green. I slowed way down, but that kind of dissonance is what we're talking about. It's hard to ignore one thing and not the other, so pretty fun. We could time ourselves and get some data that way if we wanted some seconds off of that. So, oh, by the way, this has to do with dissonance and disassociation. So it's hard for me to disassociate the actual letters of the word with the colors. That's what was giving me trouble. Some people are able to disassociate, quarantine the actual letters in the word, and they can just read the colors really quickly. It doesn't matter. Basically, the letters just become shapes. So that's what that was about. So next is free association. In your notes, for each word that you see below, don't overanalyze or basically don't edit yourself. Just go. By the way, seniors, for your thesis, when you start writing your rough drafts, you just write it. The secret to writing is just to write, and don't edit yourself before you write. Just write it. It'll be a holy mess. It'll be terrible, probably, um, but don't stop yourself. So same thing here. With these three words, go ahead. I'll give you, you know, 30 seconds each. Put these in your notes so that we can talk about them. Um, what immediately do you think of when you see the word parents? Now you've seen the other words, but here we go. What immediately do you think of? List of words or adjectives, whatever, when you think of the word school. And last one, what immediately do you think of when you think of the word love? Don't edit yourself, just go. Now, free association and pretty much all of these things that I sprung on you in a way, the only advantage to doing them impromptu, kind of reactive, is that it lowers those inhibitions or your brain doesn't have time to police itself. In more complex scenarios like relationships, basically, I'm painting with a broad brush. I'm not accusing you of anything, but basically, humans got some dark spots to them. We are animals, and sometimes we act like beasts. And it takes a lot for us to play along, to remember the rules of proper behavior. And we are always shocked when those rules get thrown aside sometimes. And so these reactive type free association or impromptu exercises are meant to try to get around that, but they're not foolproof. Some people are really fast thinkers, or some people are so habitualized that you won't get a good reaction out of them. But most of us, it works pretty well, at least gives us something to talk about. So, which brings up some problems, right? Um, these are ink blots and pictures and free associations. They are not tight protocols or procedures. And so, when it comes to research methods that we've already discussed, trying to come up with controls and identify variables or isolate variables is really, really tricky. The first example of that, and it's the largest one that I'll give you, has to do with correlation. Correlation, I think you understand, is we're going to draw a distinction between correlation and causation. Correlation is just where two things are happening simultaneously. They may or may not have anything to do with each other. If they do behave the same, is something else causing them? So is there a third factor we need to consider? And this gets out of control really, really quickly. So go ahead and write down this question and this definition, where when we talk about correlation, there's a relationship between two things, but one may not be causing the other. And I'm going to give you some examples of how this works. What we really want to look for is causality, and that is the trickiest, most layered, difficult thing to discover. If you discover a true causality, my hunch is these days it's going to be biological in nature, and for humans at least, laid down in early age. Right? Causality, or I guess later in life, or heavy trauma, right? Like war, something terrible happened in a relationship, or something like that. So There's very few things that are known to be true causes of psychological issues. They have to be pretty severe and dramatic. Okay. So, for example, some of the things that have been correlated in the past have to do with homosexuality and older brothers. Really, truly, now they have nothing to do with each other. Cavities and test scores are what I told you before. What was it? Um, Grandparents always seem to die right before midterms and finals. So, price of stock and skirt length, drowning deaths, and ice cream consumption. Um, that's drowning deaths and ice cream, for example. Like, what? It's summertime and people eat ice cream during the summer and they jump in the lake in the summer. That one doesn't have to do anything with the other, but that's how it goes. So you'll see more examples here. So you can look at these two. So what you want to see below is we're looking for positive or negative correlations. So positive correlation, if we're using XY axis, if something increases along the X axis, which means it moves to the right, there's usually, and then there's it also increase on the Y means it moves up. So you'll see that particular skew. Whereas if they're a negative correlation, it's Y increases, X decreases. No, that is X increases, Y decreases on the one with the flu. And so when you graph this data, if you see an up and down quite a bit, then there's really no correlation. We'll talk about numbers with correlation later. But if you see the average line going up to the right or down to the right, that means something. Gang, if you're bored at this point, you need to understand if you what's going on with COVID. If you look at all the data graphs right now with the up and down nature of the clustering and the outbreaks, you'll be overwhelmed because the graphs with tight restrictions, mask, social distancing, and whatnot, you have graphs that go up and down, some down and some up. It makes no sense whatsoever. Where in other areas where none of those restrictions are in place, you see clusters go up and then they drop really quickly, but that's for all sorts of reasons, from herd immunity to number of deaths. There just aren't any more people around that are susceptible to it. And so correlation and causation is the name of the game right now with COVID. And right now it is up and down consistently. So lots of correlation. Wearing masks, for example, is correlation. Studies have been trying to come out to show which masks are best or not. I think the best, strongest correlation is distancing. Right now, I'm just doing this for an example, in my opinion. The virus is attached to water droplets. Not really demonstrated that it's vaporized, except in a lab in one scenario. So it seems to be bound to water droplets. So staying 6 feet away is the best thing, only because the water droplets fall to the ground versus linger in the air. The masks, the reason there's controversy there is because there's too many mouth coverings and not enough studies to show what actually happens beyond a nice N95 with no vent on it. So that's why the debate is there, because there's a lot of correlation and causation has been difficult to prove. Okay, so I just want to help you understand. So here's an example to lighten it up a little bit, but talk about something else. So low self-esteem could cause depression. That makes sense. Or depression could cause low self-esteem. Like, what if someone has an actual physiochemical issue and they don't make enough serotonin or dopamine, for example, for new behaviors? They're going to have wrong interpretations of themselves based on the physiology. Or they could have been told they're worthless all their life, and no matter what they ever experience, they're just going to be psychologically depressed. So depression is too big of a term. And then look at the last one. What if something terrible happens, like some terrible relational or sexual trauma or warfare or family breakups, something like that? Or what if they have a genetic predisposition, like I said, like not making enough serotonin, that could lead to both of those things? So you can see how with simple examples like this, it gets out of hand. So write this down. Correlation is not causation. It just predicts, right? So if we always see one thing, maybe we'll see the other, but we don't know if that one thing is causing the other, is the way I'd say it. Okay? So these are just little examples of how you would explain these two. So correlation is important because it predicts wherever we see this, we're probably going to see this as well, but it doesn't mean it's causing it. So you could apply that to COVID. Where have the cases gone down? Where is where people have done this and that? But that may not be causing the spread of the disease nor preventing it. It could be something else. So there's other simple examples. We're done here. So all I wanted you to get across, the new thought for your brain is learning to recognize correlation versus causation, and that correlation is a predictive factor of where you might see a certain phenomena, and that's where you want to chase that down and try to push to discover a cause. That's it, gang, and we'll do some more little stuff like this for future talks, and hope you took good notes and you got something to share.